Let's find all zeros of the polynomial function here. So we are going to find all zeros of this function by first starting by finding all possible roots. So that is our P over Q process. Keep in mind, P is your constant, so that's going to be a 32 here for us, where Q is your leading coefficient, so a 3. Find all factors of those numbers. So all factors of 32, everything that multiplies to get 32. 1 times 32, 2 times 16, 4 times 8. And that's everything that goes into 32. The only way to get 3 is 1 times 3. Now you want to take every single possible combination of everything in your numerator, put it over every possible combination of numbers in your denominator. So that's going to look like a 1 over a 1, 1 over a 3, 2 over 1, 2 over 3, 4 over 1, 4 over 3, 8 over 1, 8 over 3, 16 over 1, 16 over 3, 32 over 1, 32 over 3. Don't forget that we need to add a plus or minus to every single one of these. So we don't know the signs yet, so we do take into consideration the positive and negative of every single one of these, which gives us a pretty decently long list here. I mean, it kind of is a somewhat ugly list here. I'm going to be completely honest with you here. So what we're going to have to do at this point here is we need to do synthetic division, choosing numbers from this grouping here in the hopes of finding at least 2 zeros. We have a 4th degree function. We want to try and drop that down to a quadratic. So finding one number is going to drop it to a cubic. Finding 2 will drop this to a quadratic. So we can either try and solve it or throw it in the quadratic formula here. So let's see, there's no magic in picking the right number or getting to the correct solution. Honestly, it's a matter of testing these numbers here. So let's just start with a 1 and let's see what happens. Drop down your coefficients from your polynomial. 3 for x to the 4th, negative 10 for x cubed, 20 for x squared, negative 40 for x, and a 32 for our constant. Do synthetic division. Dropping down to 3. 3 times 1 is 3. When we add here, we get negative 7. When we multiply, we get negative 7. When we add, we get 13. When we multiply, we get 13. When we add, we get negative 27. When we multiply, we get negative 27. And for our remainder, we are left with a 5. Now that tells us that 1 is not a solution. We are looking to get a 0 in this spot. If we get a 0 as a remainder, that means the number we just tested is a solution. Let's try 2. Move over the same numbers, so 3, negative 10, 20, negative 40, and 32. And let's divide again. Drop down to 3. 3 times 2 is 6. When we add negative 4, when we multiply negative 8, when we add 12, when we multiply 24, when we add negative 16, when we multiply negative 32, and we get a 0 as our remainder. That is exactly what we are looking for. That means 2 is a solution. It is a 0. We can say x does equal 2. That means that our cubic equation here, if we wanted the cubic equation, that would be 3x cubed minus 4x squared plus 12x minus 16 is equal to 0. But we're not going to do that. We're going to take these numbers that we just got here, do synthetic division all over again, which means we need to restart our P over Q process based off of our new equation. Our new equation here, our P would be a 16. Q would be a 3, right? Last number over first number. We need to restart that entire process. Anytime we find a solution here, we are restarting with the depressed equation that we get. Factors of 16. 1 times 16, 2 times 8, and 4 times 4. In the denominator, we get a 1 and a 3. So that means our list here, 1 over 1, 1 over 3, 2 over 1, 2 over 3, 4 over 1, 4 over 3, 8 over 1, 8 over 3, 16 over 1, and 16 over 3. Again, making sure that we add a plus or minus to every single one of these. Every single one of these numbers is now game. Just because we got a 2 before doesn't mean we can't get a 2 again. We do need to test every single number here. Now, because this is quite a long list, I am going to help us along here just a little bit. And let's just say I'm going to start with 4/3. And let's try that number here, which means the numbers that we are testing here is a 3, a -4, a 12, and a -16. Let's do synthetic division here. Dropping down to 3. So 4/3 times 3, throw that in the calculator. You can also think about it as 3 times the 4, which is 12, divided by 3 is a 4. When we add this, we get 0. When we multiply, we get 0. When we add this, we get 12. When we multiply, 12 times 4 is 48. 48 divided by 3 is a 16. When we add this, we get 0, showing us that 4/3 is a solution. So x does equal 4/3. So those are our first two solutions here. But again, this is a 4th degree function. We should have 4 solutions for this problem. So let's take a look at the remaining quadratic equation that we have here. This would be 3x squared plus 0x plus 12 is equal to 0. Let's solve this. I'm going to solve this by using the square root property here. I am going to subtract 12 on each side, giving us 3x squared is equal to -12. Divide each side by 3, and x squared is equal to a -4. Take the square root of each side. Square root cancels with square, leaving us with x is equal to the square root of -4. Again, keep in mind the square root of -4. We would split that up into the square root of -1 times the square root of 4. The square root of 4 is a 2. Remember that the square root of -1 is an I. So, square root of -4 is plus or minus. Don't forget that, plus or minus anytime you take a square root. Plus or minus 2i. That is our third and our fourth solutions. So a 2, a 4/3, positive 2i, negative 2i.